Good morning, everybody. Actually,
Morning, sir.
actually, that in your, I believe that in your time is good afternoon, but because I'm in the USA, so now that here is in the morning, I do appreciate that I can host this section for you guys. I know that we are United Nations, right? There are so
Yes,
many. So many of you that are from different countries that it is a pleasure to meet everybody in this section. We know that we have people from Kuwait, Sri Lanka, Vietnam, and Saudi Arabia. That actually is really an exciting event that we can join together. Today that there are six presentations so that since we only have 90 minutes, so each person will have only um, about 15 minutes. So in a sense that the presenter have 12 minutes. The reason,
yes,
uh, yes,
I'll be
yeah,
sharing the guidelines right now.
okay. And so that and we will have 3 minutes for Q&A. So just in case that uh, there are people with some question that we can actually, exchange our views and then we will have these Q&As. But as I say that since we only have 10 minutes, so sometimes that uh, we might interrupt you just in case. But hopefully that everybody can know how to control time for presentation. All right. Uh, so I just wondering that. By the way, moderator, do you have anything to say?
Sorry.
Uh, do you have anything else that you'd like to mention
Yeah,
for this?
I just wanted to start the session with a welcome note and just sharing all the guidelines with everyone. With your permission, I would like to take 2 minutes to do that.
Okay, go ahead.
All right. Thank you, sir. And hello, everyone. Good morning, afternoon, evening, according to your time zones. Dear authors and invited guests, welcome to Technical Session 6B. Myself, Priyanshi Goyal, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you all to the 10th World Conference on Information Communication Systems, Software Security and Sustainability, World S4 2026, London, UK. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in London, UK, and the virtual event is being held through Zoom from 29th to 30th of July 2026. I hope you will enjoy the knowledgeable and interactive sessions through the day. As Sir already mentioned that there are six presentations in this session. Each presenter, please note, will be given 12 minutes for the presentation and 3 minutes for question and answers. On 10 minutes, I'll be raising a gentle reminder. I request everyone to kindly adhere to the designated time. I also request to participants to check their network so that there are no challenges in between the session. And please turn on your cameras while you're presenting. Please make sure your mics are also turned off when other participants are sharing their work. At the end, I also request you to please stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in chat box. And just before we start the session, I would like to introduce both the chairs for this session, Ma'am Ruchi Sharma and Dr. John Jain. Um, Welcome, sir. We are so glad to have you with us today. Dr. Jain is an associate professor in the School of Computing at Montclair State University, USA, with over 25 years of professional, academic, and research experience. His work bridges core computer science with smart systems and advanced logic. His primary areas of expertise focus on parallel processing, computational finance, intelligent web based systems, and scientific computation using AI approaches. As an accomplished scholar with more than 40 peer reviewed scientific publications tracked across platforms like ResearchGate. So happy to have you with us, sir. Thank you so much for your words of encouragement at the beginning. and would love to have your insights during and throughout this session. I also I'm sorry, just give me a second. I also would like to introduce Ma'am Ruchi Sharma. She's a professor in the Department of Artificial Intelligence. Is my screen visible? Can someone
Yeah.
please reply? I'm not sure.
Yes. Yeah.
Okay.
It's good.
Dr. Ruchi Sharma is a professor in the Department of AI and Data Science at Jaipur Engineering College and Research Center, JECRC, Jaipur, India. With over 18 years of academic and engineering experience, her core technical expertise spans VLSI design, the IoT, power system stabilization, and artificial intelligence. Thank you so much, ma'am, for joining us today. And I, I think ma'am is still not here. She will be joining us in mid session. So without further delay, let's start with the session for today. Sir, anything you would like to add before I call out the first presenter?
Okay, so is it Dr. Shima here?
Sorry?
Dr. Shima here? No, right?
No,
Okay,
Dr.
so
Ruchi is not here.
now let's get started for the first presenter. And the topic for this presentation, as you guys can see, is
Sure.
explainable static behavior feature dataset for andranomorphic forensic and security analysis. And the presenter will be Mohammed Amula. Okay, so please get started.
Do we have you here with us, the Sir Muhammad Amullah?
Yes, I'm here.
Hello.
Thank you.
Okay.
Thank you so much, sir, for joining us. You can now share your screen.
Can you see it now?
Not yet, sir. Your
Not
screen is
yet.
not visible. Is there any technical issues, sir?
I'm trying to share it, but I should press here, share.
Yes.
Okay,
Yes. Can you please put it in presentation mode?
it's okay now.
Yes. Yes, it's visible. You
Perfect.
may start.
Okay, thank you very much. My name is Mohammed Al Mullah. Today I will talk about Android malware and some challenges in malware detection. To start with, I can say Android malware is becoming sophisticated. There is a need for accurate and explainable detection of malware attacks. Analysts require interpretable forensic evidence. Existing datasets nowadays focus mainly on classification accuracy. Our research motivation, the current datasets suffer from limited explainability. High dimensional features are also difficult to interpret. There is a need for forensic ready, analyst friendly datasets. So these datasets should support trustworthy security analytics. Our objective here is to develop an Android dataset. We call it APU for Asian Pacific University and Android dataset. It uses interpretable static behavior features that enable explainable malware detection, and it supports forensic investigations for security analytics. Some related work. Driven presented lightweight static malware detection. Andrew gave large APK repository that we utilize in our work. Tuandro MD presented machine learning benchmark dataset. So there is still a need for explainable and leakage aware datasets. Our data set consists of about 4,500 APK records collected from the internet. 4,281 records remained after we cleaned the data and removed duplications. The malware and the pinning samples included almost half malware, half pinning, and the designed for explainability and reproducibility. Some features of our dataset consist of permissions requested, API calls, file size, encryption usage, obfuscation level, network requests, suspicious keywords, network risk flag, and behavior score. These features are explained in the paper. Each feature maps a security evidence, such as privilege abuse, sensitive API capability, concealment techniques, communication risks, suspicious strings, and behavioral risk indicators. So we did a sharp analysis on these features to select the important ones among these features. So our methodology, to start with the data set, we cleaned and pre-processed the data. Then we removed duplicates. Then we evaluated the leakage aware algorithm, the group aware train test split using the app name that we developed. Then we benchmarked against multiple classifiers. For the experiment, we used 5 machine learning classifiers for group aware validation. The metrics we used are accuracy, precision, recall, F1 score, and the ROC, the area under the curve metrics. We also used sharp analysis for explainability analysis. Our results, the best model gave results was the extra trees with an accuracy of 98.72%, which is very good compared to the others. The precision is almost 99.38, the recall 98.37, the F1 score is 98.87%, and the ROC area under the curve is 99.84%. For the ablation study, we evaluated the importance of the behavior score. We also evaluated the importance of the obfuscation level. We measured performance impact when the features removed, and we demonstrated the contribution of the key features. For the sharp analysis, most influential features are the following: network requests, the API calls, permission requested, and the behavior score. Among the others, they provided a transparent model interpretation, however static. Our contribution, explainable Android malware dataset. We also call for a forensic ready feature design, compact and interpretable representation, strong performance with only 9 features, and we support security analytics research. For the conclusion of the work, the datasets achieved the algorithm, the APU Android application achieved high detection performance. It maintains strong explainability and suitable for malware forensics and analytics. Our future work, we plan to design larger datasets, do cross dataset validations, and apply the algorithm for in real world deployment. This is the presentation.
Thank you. Thank you for your presentation. It is very good presentation. Okay, so are there any questions? Uh,
Since there are no questions, sir, any
okay.
questions from your end?
Well, actually, that I use iPhone, so I just wondering that are there is any the same developed for iPhone?
Possible we might look into it in the future, I hope.
Okay, thank you. Is there
Um,
any other
I
question?
have I have a question regarding the data set. This
Yes,
one is a static data set, right? And
yes, it is.
you are collecting that only in Kuwait?
Uh, Actually, no, from different locations, but mainly
But
in the Middle East
mostly,
area.
yeah. So do you suggest that there might be differences if the same behaviors apply to the Asia Pacific region?
Possible. It should be under investigation. It's interesting,
Okay.
though. Thank you for the question.
Yeah, no problem.
Thank you. So if there's no other question, then let's move to the second presenter.
Yes, sir.
The title will be Data Asset Variation and Premium Calculation for Cyber Insurance in Sri Lanka. The presenter will be Senaya, right?
Yes.
Yes.
Yeah. Thank
Okay, so
you.
you
We
can
have you
just
here with us, Sanaya.
Sorry.
Okay, you are there, right?
Yes,
We're
I
just
am.
checking.
Yes. Yes.
Okay. Can you please share your
Denise.
screen?
Yeah. Um. Is my screen visible? And hope I'm
Yes, your
audible.
screen is visible. You may start now.
Yeah. Okay. So thank you. So good morning, good afternoon, and good evening. I am Senaya Javikrama, and I'll be presenting our research on data asset valuation and premium calculation for cyber insurance in Sri Lanka. So this is basically just a small agenda for the presentation. So just to give you a small background, so as we all know, cyber threats are increasing in complexity as well as frequency these days. So in order for organizations to stay safe and secure, they have to have really good risk management. So in risk management, after assessing and then identifying the risks, they have to treat the risks. So as you can see, there are 4 methods of risk treatment, and today we'll be focusing on risk transfer. Right, this is where a part of the financial burden due to cyber attacks will be transferred to a third party, right? And this is done using cyber insurance. So, but the thing is, the problem here is that the existing approaches that we have found out consider very much, high-level parameters, and we even reviewed a few proposal forms from Sri Lankan insurers. And yes, they do have a few security-related questions. However, those were very high level, and they do not properly capture the entire security posture of the organization, right? And they also do not value data assets. So because of that, the premiums calculated might be inconsistent and also inaccurate, right? And could be overpriced and underpriced as well because there is no standard method used. So these are just a few existing models that we found out. So I'm not going to go into it due to time constraints. Um, so the objective of our research was to basically, improve the previously mentioned problems by, incorporating the entire security posture and, quantifying the data sets to improve the accuracy of these models and equations. So the methodology of the research is shown in this diagram here. So we also conducted these surveys with banking professionals because before valuing and calculating premiums for data assets, we had to understand what types of data that they handle and they process. So this was done using a survey, and then the data was classified into a few types, based on their responses like personal data, account data, transaction data, security data, and so on. And then the final models were developed. So moving on to the developed solution. So before we move on to the models, let me just give you a small brief regarding the scores and base rates used for the calculations. So if the security posture of the organization is good, the base premium was maintained. And if it was moderate, we added 10% for each moderate security factor. And if it was bad, we added 20%. So these values were based on existing literature. So these were converted to percentage loading, so that is easy for calculations. And then we also have a base rate. So because once this expected loss is calculated, it becomes a very significant amount. And what insurers do is to bring that down, they use something called a base rate. So we use a similar method. Yeah, so to move on to the first cover, which is the business interruption cover. So this is used when organizations face, business interruption due to data maybe loss or corruption, right? So here, to first calculate the value of data assets, the downtime cost is calculated using the loss of productivity and then the loss of revenue, right? And then finally, this is multiplied by something called an operational criticality score because we want the value to represent the risk of the data loss, right? According to an ISO standard, I think it's 27005. They had mentioned that the value has to represent the worst case scenario and like the risk of data not being there. So different data types might have different operational criticality scores. So in order to distinguish this separately is why we have incorporated this new parameter so that the value will properly represent the risk of each and every data type. Then we move on to premium calculation, where we first calculate the expected loss, and then, like I mentioned before, we calculate the base premium for each and every data type that I mentioned before using the base rate, and then we add the security adjustment factors that I mentioned before. So I think I have mentioned the security factors that we have considered in our research in the paper, right? So for each and every security factor, we add the score over here, and this is calculated for the separate data types, so personal data, account data, and so on. And these premium values are then added together, right, to get a total initial premium. And then organizations can have common security factors that apply to the entire organization as a whole. For example, in this case, employee training or BCMS certification and so on apply to the entire organization as a whole. So factors like that are added over here to calculate the final premium. Right. So moving on to the next cover, it is a recovery and restoration cover. So here we want the value to represent the cost that it would take to, recover the data, restore it properly, and then secure it after, an attack has happened. So here we consider the labor cost, which could be, depending on the organization, if they have an in-house SOC or an outsourced SOC, and then the additional tool cost if they, purchase any new licenses or tools or whatever in order for this process to happen, and also any external party costs like legal fees and forensic expert fees and so on. So once the value is calculated, the same method that I mentioned before is used for premium calculation. Right, so I'm not going to explain it again because it's the same thing here as well. Um, so before moving on to the next model, just to give you a brief regarding these scores that we use. So like I mentioned before, we conducted a survey with these professionals, and most of them mentioned that they use this particular classification scheme in their banks. Right? So in order to define a score, we introduced a linear scale and then we normalized it, right? So I think in this OWASP risk rating methodology and an ISO standard, they say that we can, customize our scales and what do you call it, normalize, have a linear scale. So we did that here, and we use that in the regulatory cover. So this cover, it can be used if the organization is facing any legal fees, right, or legal penalties. So here first we calculate the value. So here P max is a maximum penalty. So just to give you a bit of context here as well. So in Sri Lanka, the only regulation with defined penalties is the Personal Data Protection Act. It's something very similar to GDPR. And yes, we do have other regulations, but they have not defined any penalties yet. So because of that, we used this particular act only here. And then we multiplied by the sensitivity that I mentioned before, and also the total number of data subjects that are potentially exposed or affected by it. And similarly, when it comes to calculating the premium, here we calculate the expected loss and then the base premium using the base rate. However, this is different here. We do not have security factors, but rather the number of non-compliances, because in the PDPA, they count the number of non-compliances, right? It's a penalty per non-compliance. So because of that, actually, when I send this a validation to a security consultant, I was told to change it and multiply it by the number of non-compliances rather than adding the security factor scores. So I changed my model accordingly. So yeah, and finally, this is just one example just to show you, how it works. And finally, the final premium for data assets is calculated by adding the three separate premiums of the three separate covers, right? So when it comes to limitations of the model, we in Sri Lanka we could not find any quantitative equations or models that insurers use. So because of that, it was very difficult to conduct benchmarking. So instead, like I showed before, we used test values for all three models and tried to see if the premium increases as the posture worsens and if it decreases as security posture becomes better, right? And we also did not have real world numerical data sets because the banks and the insurers were a bit reluctant to provide them to us. So hopefully, in the future, we will be able to maybe execute NDAs and make this possible. And also applying this to other industries and sectors I mean, it's not really a limitation, but it will need a bit of additional research to understand the data types in those particular industries as well, right? So that is mentioned under future work. So that is the end of my presentation. Thank you.
Thank you very much for your presentation. Are there any questions? I just wondering that since that the bank and insurance company, the data are protected. So if you really want to do the future work, and how do you retrieve those data?
Yeah,
Is it
that's the
possible?
thing. I think we might be able to maybe sign some NDAs or data protection agreements with them. Very much that is our plan actually, but very much depends on their response as well, because banks handle a lot of sensitive data, right? Like very confidential data. So maybe at least with the insurers, hopefully it will be possible in the future.
Yeah, thank you. So, any other questions? Okay, thank you for your presentation. And so let's move to the third presenter. Okay, the topic for the third presentation will be major specific influences of blended learning in higher education. And the presenter would be Nguyen Van Kiep. Is he here?
Do we have you here with us, sir?
Mhm.
I can see you are there, but I cannot hear you.
Yeah.
Sir, you're not audible.
Can you hear us?
Yes, Professor.
Oh, maybe you should you should turn your volume up if possible.
Yes, of course, Professor.
Ah, oh, thank you. Yeah, go ahead.
Can you
So,
please share your screen?
yes. Can you see my screen, Professor?
Yes, yes, sir, it's visible. Can you
Yes.
please put it in presentation mode?
Yes, thank you.
Yes, you may start.
Here is my presentation. Professor measure specific influences of blended learning in higher education. We set up the study in the university in Vietnam with more than 9,000 students in the 2 year, 2033 and 2034. Introduction and motivation. And understand the role of blended learning system in different major contexts, university setting, educational university. In two major SCI, it means the social science and engineering science. The first one is about the blended learning system. Blended learning system is a system combine online instruction and the traditional instruction, face-to-face teaching, offering various learning resources, personal learning activities, and authentic contact learning. But beyond our literature review, we found that previous study have not yet studied the difference between the different major university students. So it reason why in the study, we want to conduct the study based on the larger sample and to know how the difference between the traditional one and the blended learning system. The second question, we want to explore what difference are found in the learning achievement between the two main major student categories, social science and the engineering science, learning with the blended learning system. They are the two main questions in the study. About the methodology and system framework, as I mentioned at the beginning of the presentation, we based on the R9 with a larger sample in the 2 year academic year, 2023 and 2024. It means the result of the student in 2003 and 2004. Of course, our school year, of course, is a 2023, 2024, and 2024 and 2025. But we combine with now blended learning system in 2023 with blended learning system in 2024. The year 2024, we conduct and we use a blended learning system applied for all of our situation in our university. The blended learning system conducted in our university, there are two main parts, teacher, learner, and the learning resources. Learning resources is here we prepare by the teacher. And before give to the provide with the student, we also prepare carefully by on the suggestion and by on the review, peer review of core colleague. After that, we also prepare the assignment or project provide to the student. Of course, we also review before we upload in the system. About the learner, they also approach the learning resources by themselves beforehand, before they come to the classroom. And they also provide the learning material and the learning resources can read, can study before come to the classroom every lecture. And also the authentic contact learning based on the app, based on the website platform, the student can access, the student can learn, the student can do exercise, everyone, everywhere they want. This is something about our framework and the learning system. In the classroom, the teacher and the student can discuss about the topic, and also the teacher can explain or guide more detail about the something um, student want to ask or student want to clarify. Here is the data set. We also based on the 247 courses. And also we categorize 2023 and 2024 with and without blended learning system, categorize social science SCI or engineering SCI majors. The result and the empirical analysis. Here we compare the A, B, C, D, F score between 2 years and between two major. You can see here with the score A and B have a increase in the blended learning year, school year 2024. And also the percentage of B and C score also improve. It means the high scoring, a high background, high ability student improve when learning with the blended learning system. Next one, we also use the post-hoc analysis to compare between the major difference and between the without and with blended learning system. So you can see here, and we found that the SCI here, you can see here, SCI CI in 2024 more than higher than SCI 2024. It means the SCI social science gain more benefit, right? Gain more benefit
Not
than
at all.
yes. It is the important result in the analysis. And the next one, you can see here, we also got some explain from teacher and from the student, and we found that the teacher says that maybe social science they access based on the knowledge. Why the engineering student, major student, they access based on the practice and skill. It's different. It means the skill and practice in the engineering major maybe it is more difficult than the knowledge, because knowledge of the student based on the real life, right? Real life situation or the their own background, their own knowledge, previous knowledge in their life and in their real life situation. And another one maybe some low score student, maybe they lack of support from the teacher, lack of support from the instructor or school staff. Is the reason why they still find difficult to improve their learning achievement. This is some reason we want to explain in the beyond the result. And next one is about the contribution of the study for the community. We also we want to impress when educational setting apply blended learning system for different measure. Maybe it is more useful for social science measure, and maybe the moderate and the high
It's a gentle
student
10
performance.
minutes reminder.
Yeah, it is better. And is also move to the conclusion of the study. We also want to improve our study with more various major in university and more different university because study still implement in our university with about 10,000 students, maybe open the other one. And also the framework, we also want to conduct and design for different student ability, low student ability and high student ability with the different learning resources or different guidance or support and help, something like that. And yeah, it is that all. We want to discuss more if you want to any question. Thank you very much.
Thank you for your presentation. Is great effort that you guys conduct such a great experience. But is there any question from audience? I just wondering that now that students use AI, so I was wondering that the accuracy of your assessment to assess the students' performance and would if students use AI, would that affect the outcome? Because we always have that problem in our student. If students actually use AI, they might perform better in homeworks and so on. So I don't know, in your opinion about that.
Thank you, Professor, for your question. We also consider about this, Professor. We also worry about the AI, but in the system, Professor, we of course homework or do exercise, student, okay, do free time, and they can use the AI or ChatGPT or something like that to do or finish their project or assignment. But when at the end of the courses, student also attend some exam, and the study will also based on the score of the exam, Professor. Yes, for the exam. So of course the close exam, not open exam. So they yeah, both social science student measure and the engineering student measure also, both of them have to do the exam, close exam, with beyond the system, Professor, beyond the system.
Okay, thank you.
Yeah,
So,
thank you.
is
Thank you
there,
very much,
yeah,
Professor.
thank you. Is there any
Thank you so
other
much.
question? All right, so now let's move to the first presenter. The topic for the first presenter is a new novel, volumetric editing for dynamic 3D Gaussian splitting, a systematic literature review. The presenter would be Jennifer. Is it Jenny? It,
Hello, am
Mr.
I audible?
Janet.
yeah,
Yes,
it's
you're
here.
audible.
Okay,
Okay.
with you.
Can you please share your screen?
Yes.
Yes, your screen is visible. Can you please put it in presentation mode?
Yes.
Yes, you may start.
Okay, so hello everyone. My name is Jansu Sanayakar, and today I will be presenting my paper, a systematic literature review on neural volumetric editing for dynamic 3D Gaussian splatting. So this work has been completed with Mr. Pumud Fernando and Mr. Malul Singh. We are from Informatics Institute of Technology, Sri Lanka. So in this presentation, there are four main parts. The first one is I'm going to talk about the background, technology, and the problem that we have identified. And after that, the method, the systematic review process that we did, and the paper selection, and the findings, the three main editing paradigms that we have found, and they are trade-offs, and followed by open challenges, and the future directions. So talking about the background and the technology, uh, when we talk about three-dimensional scene representation, so if you take a game for example, as of now, 3D objects are created with mesh-based rendering. So it's important in many areas, including virtual reality, augmented reality, video games, and creating digital twins. So traditional 3D scenes are often represented using these meshes, and these meshes contain vertices and edges and faces, so it's easier for them to edit. So when it comes to creating complex visual effects like smoke, fog, or transparent objects, it's a bit difficult using mesh-based rendering. So they have introduced something called neural radiance fields, which is which uses a neural network to actually represent a 3D scene. It uses a method called structure from motion to actually capture object from different angles, and it can create a 3D digital copy of that object. So since neural radiance fields uses a neural network, it's really slow to render a scene. So 3D Gaussian splatting has been introduced as a faster alternative to actually represent the 3D scenes. And this uses kind of a 3D primitive. It's a kind of a collection of a point cloud. And this Gaussian has the properties of scaling, position, and rotation, and opacity and color. And it can create really photorealistic scenes. So because of this, faster in this makes it attractive for virtual reality and some standalone VR headset, because this is real-time compatible. So the problem that we have identified is when these 3D Gaussian splatting scenes are rendered, it uses this point cloud. Unlike 3D mesh-based rendering, it doesn't have any smooth surfaces or edges that we can edit the scene. So if we try to edit some scene like this, it would actually cause flickering. And so when we do an edit in 3D Gaussian splatting, it must remain stable across every frame and every viewpoint. So for an example, if we try to edit the color of the scene, for an example, this is a 3D scene rendered using Gaussian splatting. And if we try to edit this color of this scene, it creates kind of a flickering issue. So we have called this the consistency gap. And this is the main problem that we are addressing. And moving to the main aim of this research, this research was to actually review neural volumetric editing methods for dynamic 3D Gaussian splatting and related to neural radiance fields. So we have structured this research around three main questions. The first one is what editing methods currently exist for dynamic neural volumetric representations, and how do these we have found out three main categories for this: text guided, interaction based, and physics based. We will explore that in the coming slides. So how do these methods compare to each other, and what technical barriers prevent real-world adaptations and production use of this rendering method? So For the methodology, we were guided by the Prisma 2022 framework, and it helps us clearly explain how the papers were identified and screened and selected. Also, our main sources were IEEE Explore, ACM Digital Library, Archive, and Google Scholar. So the search focus was actually the technology is called 3D Gaussian splatting, 4D Gaussian splatting, neural radiance fields, and specifically, since we are focusing on editability and control of this technology, text-guided editing, drag-based editing, and physics-based editing to actually uh, explore them. So also, we used references from other important papers to get new papers and cite them. So in the first screening, we have found 71 candidate records. After filtering out the duplicates and non-relevant records, we found 37 unique papers that we screened. From these, we have selected 15 primary studies, which focuses on editability and control within 3D GS. So there were 22 other supporting papers as well to get the evaluation matrices and the data sets, and also comparing the future directions. So the three main categories that we have identified in this is first, text-guided editing. So this uses natural language to actually edit a scene. The second one is interaction-based editing. So this is kind of typical editing software like Blender. So it uses drag points, handles, and nodes to actually edit the 3D object. And the last one is physics-based simulations. So in this category, the scene is edited using physical rules such as gravity, collision, or friction, and or elasticity. So let's go ahead and explore each of these parts and how see how they compare. So the first one is text-guided editing. So in this one, it's a kind of a simple prompting method that you can actually change a 3D render using text. So this uses a diffusion model to actually change the scene. And this is an earlier method that uses NERFs method, but more recent one that uses 3D Gaussian splatting is much faster than NERFs because since NERFs uses a neural network, it takes a lot of time to actually render a scene. So so text-guided methods have many limitations. So if you try to, the first one is a weak localization. If you try to edit a specific part of the scene, it could actually bleed to other parts of the scene, and it could disrupt the scene. And some method needs repeated optimization, which to improve the quality. And so after creating this edit, you have, if you view it from different angles, it should uh, stay consistent, but in this case, it shows flickering. So the next one is interaction-based methods. So interaction-based method provide more of a direct control. So this kind of you have control nodes to actually take control of the scene. So this is a 3D render, and this is example of interaction-based edit. Uh, so the main advantage of this one is precision. The user can directly indicate which part of the scene should move or deform. So these methods are useful for object movement and local deformation and animation style editing. So the next one is physics-based simulation. In physics-based methods, they use physical properties such as gravity and mass, but one of the issues of this is it's computationally heavy. And also, since 3D Gaussian splattings are rendered using multiple images captured from different angles, uh, you know, taking physical information like mass, stiffness, or friction or elasticity from a single image can be challenging. So it's a issue. And
Could you
also,
check the
since
10
of
minutes
the
reminder?
main restrictions when it comes to the performance, it's difficult in standalone hardware. Also, comparing the main findings, nerve-based editing usually requires repeated neural network queries and long optimization times, and 3D Gaussian spreading provide much faster rendering. However, faster rendering does not always mean fast editing. Some of the 3D editing methods require several minutes after prompting, as for an example, text-guided editing. So interaction-based methods can provide accurate control, but they struggle with topology changes. If you try to move the object, as we saw in this scene, it deforms the object and change the topology. So for this, there is no single method that actually can produce high precision, fast editing, low memory usage scenes. So talking about the future directions, first, it should focus more on the temporal consistency. That means the frames must be consistent throughout the time. And future systems could also reduce the memory computational cost by actually compressing the image files and uh, maybe improving the workflow. And this may require Gaussians to be created, removed, or merged and split during an edit. And text prompts can provide high-level instructions as well. So as a conclusion, uh, we have grouped and reviewed three main categories: text-guided editing, interaction-based editing, and physics-based simulation. Uh, the main finding is that the consistency gap remains the largest barrier when it comes to future adaptation and real world use. Yes, thank you very much. That would be end of my presentation.
Thank you so much,
Thank you.
sir.
Yeah, thank you for your presentation. Well, it's very impressive, and thank you for thoroughly review all this is 3D editing methods. But is there any question from audience? I just wondering that since that now the technology is kind of pretty mature, would that affect like a deep fake and also the like movie industry in the future?
Yes, actually, this is actually based for real-time editing and photorealism. So this means this will be used for creating virtual avatars as well, and it has the issue of deep fakes and other unexplored areas of yeah.
Yeah. All right. Okay. Thank you. Any other question? Okay. Thank you. And let's move
Thank you.
to the next presenter. Okay, the next presenter, the topic we say well, a signal quality aware multimodal machine learning framework for the real-time physiological state monitoring and transition detection and anomaly safety in wearable system. The presenter will be Mazin Asha Arani.
Do we have you here with us, sir?
Yeah, speaking. Assalamu alaikum. Hello, everyone. It's nice to be with you guys today. Shall I present?
Yes,
Yeah,
you may
yes, please.
present.
Yes. Okay. First of all, thank you for this opportunity to present one of my research activities that I work intensively in the last few years. I work with machine learning and for different purposes and provided it for physical implementation like what we're gonna present today. I'm gonna speak about the SafeWare, which is a signal quality aware framework for safer, smarter wearable health monitoring. Um, as much of you know, the elderly percentage in the world is coming increase in the last few decades. So aging population creates healthcare problems, burdens. Clinical-based elderly care is insufficient in some countries, and or most of the countries. While continuous monitoring needed for these type of people for early detection and prevention system. That's why we can see easily in different countries like US and Europe and Asia, the population based on the World Health Organization increased for the aging people, which mean that we need actually technology to be activated and evaluated in the providing better systems based on the AI and machine learning and different stuff for this type of services. We can see, as mentioned, this is just general information that can we build our idea and how this importance of this such a solutions. So yes, the aging is coming up, and what we can see by 2035, also the aging, of course, in the ladies is higher than the aging average in the males. So, what we think about was how can such technologies, different technologies like remote monitoring using technologies, can provide such a monitoring solution, because most of the problems comes from the after effect of the problem. So we gonna use a prevention system regarding to use a post system that can cover the solutions. This is architecture that overview. The sensing layer is in the left hand. Those are sensing layers like an sensor can be used in different type of wearable devices like Apple Watch, Android-based watch devices. And there is in the middle here we can see the edge cloud processing layer. So where is data collected, analyzed, and machine learning models works. So in the clouds and provide different results can be used and analyzed in different usage for the user, the caregivers, the clinicals. In general, this is exists now. So the focus in our research or our approaches was how to focus on the pipeline of the data collected and to provide a safe way of listening to the data and transferring it and checking this data with different stages because the stimulus collection is okay in level, but the analyze and the analyzing and with using different models is the challenging issue that I'm tackled in this research. So analyzing in parallel, so and providing the alert. So we designed a safe where pipeline and we choose here the inputs and the different stages. We have four stages to take the signals and analyze it, and then go to the transition detection model with different models of machine learning models, and the outputs will go with the fusion and detection layer. At the stage of four, we find the anomaly and OODs based on these signals collected. So in our research, we have identified two main gaps. So in the wearable health monitoring is the transition gap and the signal safety gap. Those are very common main problems in the wearable devices. So how to be to move these gaps to and provide solutions using the right models that we can work with in safe wear presented approach that we speak about it. So the two models are fairly focusing on the transition detection and the anomaly out of distribution or OODs. These are depends on different type of models in in machine learning, well known by the familiar people with machine learning and AI solutions. So this is called the transition will predict the psychological and differentiations in the readings and give flags whenever it's needed. And also the anomaly also provide a way of detection and comparing across different family of models of machine learning well known by the special people who work in this area. So um, in our study, we used by to collect from 37 healthy adult people using five basic wearable signals. We used about 41,000 second data window analyzed for different activities like stress and aerobic and anaerobic activities. These are the type of signals that we used. Blood volume and electromedial activity, heartbeat, skin temperature, and body motion, the AACC. So the stress was based on the activities. We can say that we have different variation for different activities based on the tested portion of people. So the results based on the models we worked, so the prediction of the before things happen or change over the models, we found different percentage in different results. That means every model has its own capabilities and usability based on the detection speed. So we have high detection speed in the transform model, while in the XG boost was the lowest detection. That's why we can identify from here the best models can be used in our prediction for such a model, such a scenario. Also, in the safety net for unexpected, so the deep SVDD also considered one of the best approaches and over the used model in our test. One of the interesting surprising finding that we have, we found that the paradox of the temperature is not to use too much sensing signals. That's why too much signals will, of course, affect the quality of the readings, especially in temperature, or also and also the motion. So we need to identify different motion patterns that we depends on to collect to in the collected data that can be identifying different issues in our readings. Um, this is also showing that we have enough to run tiny low-cost computers using our models. These models providing high and excellent results that can motivate us to go deeply with implementing machine learning instantaneously in the meantime of readings that will provide an agile or fast decision making and flags raising and alerts for the if needed based on the readings we have. So, in recommendations, practical guidance for deployment is very important. So we have to have gate on signal quality. It's very important. So also we need to identify the 10 thresholds and add a delay filter. Then we need to choose the right TCN on device use and the preferred learning model for anomaly detectors that can be used in our detection system. Future works will focus more in the personalization of these readings for each model and activity and age group. So also the border anomaly types that we can be used, also the validation of these data and the combining scoring of new populations as well. In conclusion, we have our casual models that can detect transitions in under 5.2 seconds, which is very high, by the way, in catching over 79 as an early signals can be identified. So also deep SVDD and VAE
Exactly
is
10 minutes
specialized
reminder.
give most reliable and cross-person anomaly discriminations. Also, temperature and motion paradox reveals that not every sensor always helps. The full pipeline is light enough to run in real time in lower power wearable hardware. That was all what I have for today's presentation. If you have any questions and suggestions, please let me hear, please.
Thank you so
Thank you
much,
for your.
sir.
Yeah.
You're welcome.
Any question? I did, thank you for your good presentation. Actually, that you talk about very important topic, and I just wondering that because you said that more sensor not necessarily is good, but how about if the computer's speed and cost and performance actually improve? The reason I say that is because, say, for example, in Tesla they have 6 cameras, so they can do full self right now. Now actually that only they can do the full self drive, which is in the United States, and others cannot because they have a good sense and they can process very well. So I just wondering that in the future, just in case that the cost of the computer actually drop, is there more sensor maybe can improve, especially in the healthcare industry? So what is your opinion?
Yeah, this is a cloud-based solution. So whenever we raise our solution on the cloud, we rely on the cloud services. So whenever we have a good cloud system with our current capabilities, it was fantastic. For future, I think the speed will be multiplied by different numbers. So these variations is very important in collection in the quick interruptions and quick alerts for the doctors and the system. Whenever someone fall down in house, an elderly, imagine that an elderly alone in house, and there is a delay in signals. This is bad for signal decision making system. What we need in this system is to have as soon as possible signal alerts and flags that can help us to provide safe and fast services based on AI and machine learning.
Thank you.
Thank you very much.
Any other question?
I don't think there are other questions. Moving forward, I would
Okay,
like to.
so yeah, go ahead.
Yes, sir. Okay. I would like to request Sir Huang Dion to kindly present his paper titled Trust in Digital Public Services in the AI Era: How Information Security Perceptions Shape Engagement with Vietnam's E-Government's Education Platforms. Do we have you here with us, sir?
Yes, hello.
Yes, you're audible. Can you please share your screen?
Okay. Give me a second. All right. Is it visible now?
Yes, your screen is visible. Can you please put it in slideshow mode?
Okay. All right. So this is it's visible now, right?
It's not in slideshow mode. I think it's stuck a bit.
Um, is it in slideshow now?
No. Can you stop sharing and reshare?
Okay.
Yes,
Should be
it's
on.
visible now. You may start.
All right. So thank you, Professor and the organizer. So I'm from the Hanoi School of Business and Management under the Vietnam National University. So today the topic I'm presenting it's trust in digital public services in the AI era, and this is mainly a synthesis paper. It's based on an ongoing research at our institution. Okay, so the central idea is that educational platforms, especially those that are embedded with AI, is becoming more common in Vietnam in terms of the public digital infrastructure. And trust is an issue because with the system getting more complicated, um, it's hard for the user to determine by themselves, if the system is technically secure, partly because maybe due to their um, expertise or knowledge. Yeah, but that is also an obstacle for the government to roll out new features and new platforms. Sometimes it has frictions and resistance. So this synthesis paper is trying to suggest certain areas that m- different governments need to look at when they want to roll out digital services, especially in the uh, education sectors. Okay, so this is one example of the kind of e-governance education platforms that are implemented in some of the universities in Vietnam. Right, so it's getting more complicated, like one app and multi-functions platforms. Okay, so in Vietnam at the moment, education is a main focal point for digital transformation. So, for example, at our university, the students would go through one interface to register their courses, access learning materials, receiving grades, submit assignments, and communicate with the institution's departments. This system are convenient, but they also collect personal data and they store academic data. So that means that these platforms also presents not only educational issues but also governance and trust issues at the same time. Okay. So universities, especially big ones, from our point of view, it's considered public services, and they can be e-governance nodes. For example, the Vietnam National University has around 80,000 students and around 7 to 8,000 staff. So it's a very big organization. Okay, so um, this institution, through their governance platforms, they are managing identities, records, they have data histories, they have payments, and sometimes even behavior data. So when this platform fail, and sometimes they do, due to hacking, due to poor maintenance, the impact is not limited to one institution. So it can affect students, lecturers, partners, collaborators, and therefore would reduce confidence in digital learning, and uh, it becomes a broader trust issues when many of the educational institutions in Vietnam are moving to, or at least plan to have a common platforms managed by the government. So the question is not only about if the platform is working; it's also about if the user is finding the platform secure, fair, and accountable. Okay, so um, we through the synthesis, we found out the main problems, at least by the literature review, that there is a trust problem because users they cannot directly inspect the security architecture due to um, the data protection, integrity issues, and also IP, right? So most students, therefore all the users, cannot verify encryptions, access control, server configuration, or the cyber security governance rules. So instead, they only rely on visual cues like how the interface looks like, how does the login feels like, or is there any privacy notices or any like notifications on the platform that can tell them that this is somehow secure and they can trust the system. But that is clearly not how it works. Based on the synthesis papers that the papers that we have, synthesis, and also via common analysis and and others. Okay, so this is a gap, right? So mm, on on the background, or we call it the back end, right? Technical security can be achieved, but that is only visible to those people that create the system, but not entirely visible to the users. Okay, and that has created tractions and students and user, you know, inconvenient feedback of many system in Vietnam in general. Uh, okay, and for the policy wise, Vietnam is very aggressive in its digital transformation agenda. We have many decisions, many regulations and plans governed by the Ministry of Education and also the government. Data protection context is also getting more recognized. Therefore, trust is also one issue that the government is looking at very carefully. Okay, for the implementation gaps, the literature would suggest that the implementation remains uneven because Vietnamese higher education still face differences in technical infrastructures, in staff digital capacity, legal clarity for such online platforms, and information security readiness. And also, those research would also suggest that the policy documents often emphasize administrative roles and um, duty rather than enforcing or raising awareness about learner privacy or cybersecurity. So this creates a situation where national ambition is strong, but user level trust is not easily measured or cannot be assumed. Okay, and with the current push of AI, it becomes maybe even more dangerous in a sense, and it makes the trust problem more complex because the educational platforms is increasingly using adaptive learning, AI automated assessment, AI personalized recommendations, and other learning analytics. And there has been incidents in Vietnam regarding data leakage and hacking due to the usage of AI in the system. Some just happened like a few months back in Hanoi. So these features would process behavioral and performance data, and when AI is involved, students must trust not only that their data are stored securely, but also that the AI decisions are fair, explainable, and accountable, which cannot be 100% all the time. That we know of AI, they sometimes hallucinate, and we cannot trust them to make the correct decision all the time. So this present the AI risk in education. So there are several risks beyond the traditional cybersecurity, including the privacy and security vulnerabilities due to inaccurate outputs. Sometimes we call it the uh, in prompt injection or prompt poisoning in the AI. Right? the AI bias, the academic integrity concerns, and unclear responsibility when the AI assisted decisions it's ambiguous, right? For example, if the AI decide if some assignment is plagiarized, some is not. So we have had many conversations going about this AI
It's a gentle
detection.
10 minutes reminder.
All right. So for the research questions, we are focusing on trust, intention to use, and this is based on 60 records exported by API from the Scopus database. Um, Theoretical foundation is based on the TAM model and PMT, also using a CIA triad for reference. And the main finding it's that there are a few literature streams such as the e-government trust, security and privacy, AI governance problems, and for example, in the Vietnam context, there are especially trust problems in higher education platforms, and um, there are too many policies going on that to achieve proper administrative management for this platform is challenging. And the main synthesis of the paper is that the students may recognize the risk, but they may not fully understand it, and they would still continue using the platform because the usage is required and convenient. But trust remains important, especially for deeper engagement, such as sharing personal information and accepting AI supported recommendations without questioning, right? And the policy implications that the paper is proposing is to align platform governance with local regulations, and also missing here it's the international
I'm sorry to interrupt,
standards.
sir, but the 12-minute mark is up. Can you please conclude?
Okay, thank you. So this is the limitation in future research requiring longitudinal studies. Thank you for listening.
Thank you so much. Are there any questions?
Thank you for your presentation. I just wondering that is there any regulation and policy using AI in education, or maybe the government or your universities that try to? Yeah.
So the current AI regulations is mainly uh, institution based. So each institution would implement their own AI guidelines, and there has not been any guidelines, especially regarding plagiarism in Vietnam.
So what is the tendency for universities toward this using AI in the
Um,
educational environments?
Yeah, so it's mixed. So for the technical institutes, they are pushing this a lot, but for the um, like social sciences people, we are conservative about this. So
Okay.
it's really taking time because especially for non-English speaking countries, when students submit their assignments and there is no grammar errors, no spelling errors, and it's very unsettling for the lecturers to read those assignments and to actually assess the students properly.
Okay, thank you. Thank you for your presentation.
Thank you.
Thank you so much, sir. And with that, we have come to the end of this session. I sincerely thank all the authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 10th version and all the previous 9 versions of the conference. We'll be happy to have you in the 11th version in 2027 as well. Please note that all the presenters will be getting their digital certificates through email within 2 working days, and the publication will be live within 7 to 8 months. Kindly cooperate with the team of WorldS4 2026. I would also like to thank our session chairs, Dr. Shruti Sharma and Dr. John Jain, for chairing the session. Here's a small token of appreciation to you, sir, uh, for chairing the session and for your contribution to this session on behalf of the team of WorldS4 2026 and Global Knowledge Research Foundation and partners. Thank you for your valuable presence. Before ending the session, I would like to request you for a few kind words about what do you think of the session of today?
A very, very good presentation. Actually, that I find out that especially for young researchers, and I do appreciate the effort that people actually put in to do such wonderful and quality research. So keep up the good work.
Thank you so much, sir. Thank you everyone for your valuable presence. Before ending the session, I would like to request everyone to please turn on their cameras so that I can take a snapshot. And with that, we will end the meeting. Okay, I'll be taking the snapshot in 1, 2, 3. Thank you so much, everyone. Please have a good day. Bye-bye. Take care.
Thank you. Goodbye,
Thank you,
everybody.
Professor. Thank you, everyone.
Thank you.
Bye bye. See you.
Thank you,
Bye.
everyone.
Have a nice summer.